Assalamu alaikum students, hope you are doing great. Another video on O levels computer science. So we were on data transmission, and in this video I'm going to tell you that how parallel data transmission works in integrated circuits, right? So before going into the parallel data transmission in integrated circuits, let me first tell you about what are integrated circuits. So let me share the definition of integrated circuit first. What are integrated circuits? So an integrated circuit is a group of electronic components interconnected on a single chip of semiconductor material, or we can call this chip as the silicon chip. In order to fulfill in order to fulfill a specific purpose, right? So this is the definition of the integrated circuit. It is basically an integrated circuit is a group of electronic components. Group of electronic components means that it can have various resistors, it can have diodes, transistors, or if I talk about digital ICs, then there are logic gates. So these are what? These are basically the different components, electronic components that are interconnected on a single chip, right? You are having a single silicon chip in which you are having different kind of components that are connected with one another for a specific reason. Why I have written that specific reason? Because let's talk about an example. I have an integrated circuit. Let's take an example of adder. Yes. Adder is basically a type of integrated circuit that is used to add two numbers. Yes. Let's suppose this is a circuit. It's a silicon chip in which I'm having different kind of components that are connected with one another. I'm not going into the detail of internal circuitry. Why? Because in this video, I wanted to tell you the parallel data transmission in IC. Okay? So it is not related to the internal circuitry. You should know that IC is basically the components, electronic components connected to one another, and why they are connected in order to fulfill some kind of function or some kind of purpose. So let's talk about an adder. In an adder, you are going to have two inputs that are going simultaneously into an integrated circuit or into the IC. And when this IC takes these inputs, this is input number 1 and this is input number 2. Two inputs are going into the circuit and it is giving you a single output. And what is the purpose of this adder? It is going to add the numbers, right? The inputs that are received to the adder 1 and 2, these two inputs are going to be added and it is going to give me the result of it at the input line. So this is the purpose of adder. But besides the purpose, you can see that here two lines are given for the inputs. Two lines means that data is transmitting simultaneously through two different channels or through two different wires. There are two wires that are used for data transmission. At the same time, you are sending two inputs. So this is where the parallel data transmission comes, right? Let's take another example for you in which I'm going to share this parallel data transmission in detail. Okay, so what is it? This is basically the picture that is shown to you. It is basically the multiplexer. The name of this particular device that is shown to you is multiplexer, or if I talk about the abbreviation, then this is MUX, MUX, right? So multiplexer is again an example of integrated circuit in which you have various components that are connected in a single chip. And what is the purpose of this multiplexer? It basically selects one of the input to be sent to the out. Yes, it chooses which of the input must be sent to the output depends upon the control signals. Why? How it is going to choose? It is going to choose by taking decision. And that decision is taken by looking at the control signals that is being sent to the multiplexer. Let's suppose it is 4 by 1 multiplexer. 4 by 1 multiplexer means that it has 4 input lines. We can easily see that here, this is the input line where the input is going, right? 4 into 1 means that it is going to have 4 input lines. 1 input, 2 input, 3 input, 4 input. So this is 1, 2, 3, 4, 4 input lines. And in the multiplexer, you are going to have a single output line. That is why it is 4 into 1. 1 is for output and 4 is for input. So 4 by 1 mux represents 4 input lines and 1 output line. And what is the purpose of multiplexer? The purpose is to select one of the input to be sent to the output. It chooses one of the input. So the decision is taken by looking at the control signals. Okay, let me tell you a little detail of it. Okay, let's suppose if I am having two control lines, then I can have four different data that can be sent. Keep in mind that you can send one bit in one line. Let's suppose I'm sending 0 here in this wire and I'm sending another 0 in this wire. So there can be four different combinations of sending the data to the control lines. Either the control lines are going to give 0, 0 to the mux, or it can give 0, 1 to the mux, or it can give 1, 0 to the mux. Why? Because we know that there are two combinations of sending bits, either 0 or 1. You can send two type of bits, 0 or 1 to the input. So if these are two control lines, so the combination becomes 0, 0, 0, 1, 1, 0 and 1, 1. These are the four inputs that can be sent, four different inputs that can be sent to the control lines, and upon these inputs, upon these control signals, the decision is going to be made that which of the input needs to be sent to the output. Let's suppose the multiplexer sends, the control signal sends 0, 0. 0, 0 means that this particular rotatory, this red arrow, that red arrow that you can see on the picture is known as rotatory signal. This rotatory signal sets its position when it takes the control signal. Let's suppose if it takes 0, 0, then it sets its position to I naught. Right? The I naught line will be connected to the output. And if the input that is sent is 0 1. Let's just let me write over here. If the control line sends 0 0, then the rotatory arrow will be set to I naught and the input I naught will be sent to the output. If the control signal sends 0 1, then the rotatory arrow will be set over here instead of this, right? And then I1, input of I1 will be sent to the output. And if the control signal gives 1 0, then this rotatory signal will be set to I2 instead of I1. Similarly, the last option is if the control signal gives 1 1, then the rotatory signal sets to I3. And this particular path, the path of I3 will be enabled and the fourth input is going to be transmitted to the output. So in this way, it depends upon the control signal which of the input is going to the output. And keep in mind that since you have multiple inputs, look at here, you have multiple inputs that are transferring, that are transmitting to the mux, to the device. So it means there is parallel data transmission that is going on. Parallel data transmission. So I hope this is clear to you that how you can use different kind of integrated circuits for parallel data transmission, right? So I hope this video is helpful to you. In the next video, I'm going to give you the example of serial data transmission, right? So keep watching, stay tuned, stay connected. Take care.